Hi, hello, who are you? My name's Anna Benson. Welcome back to my channel. We are going through these LeetCode problems here, and we're on problem number 64, the minimum path sum. And I have already done this one. I did this like 15 days ago, more than that, on September 15th, I think. And it did all right. It beat 49% of users in memory and 84% of users in runtime. Would have loved to just inch it right over that 50, but we are close enough where I am satisfied. Satisfied. So you guys are more than welcome to read this question on your own time, but a summary of it is you're just given a grid with values and you need to find the minimum sum of values while moving from the top left to the bottom right corner by only moving right or down. So similar to the previous two problems with unique path and unique paths with obstacles, I tackled this a very similar way. Instead of, I think I started it the same too. I can't entirely remember, but I started by calculating the number of rows and columns as the grid. So we just initialized M and N, which are rows and columns. We then had the DP, which is a 2D array matrix of the same size as grid, filled with zeros initially, the same as we had before, which would store the minimum path sum for each cell. And similar to the last one, we have DP00, which is set to the value of the top left cell in the grid. So this just initializes the starting point. We then have these two loops, these 4J and 4I. They calculate the minimum path sum for the cells in the first row and the first column on the previous cell's value and the current cell's value. The nested loops that we have iterate over the entire grid except for the first row and first column, and we just calculate the minimum sum for each cell, which is just done by taking the minimum of the path sum for each cell above and the path sum for the cell to the left and adding the value to the current cell. So we then bring back this DP M-1, N-1, which just contains the minimum path sum from the top left to the bottom right. And that is how we are using dynamic programming to do this one more time with feel pretty good in this unique path situation. So that is my explanation of this solution. And again, this is going to be available in my GitHub repo, which is available down in the video description down below. You are all more than welcome to fork and clone, make it better, make it worse, have some fun, learn something new, and hopefully I do not have to do another unique paths code for at least 10 more problems. And thank you guys so much for watching. I will see you in the next video. Goodbye.